and matter. Everything which has got some weight, occupies some space and attracted by earth is called matter. Example: book, chair, vapor, soil, and air, etc. Molecular theory of matter. Every material body is made up of tiny particles known as molecules. These molecules are in continuous motion and there is a force of interaction in between these molecules. It is also called kinetic theory of matter. Postulates of kinetic molecular theory. One matter is made up of very small particles called molecules. Two molecules are in the state of motion, which may be transmission, vibrational or rotational. Molecules possess kinetic energy due to their motion. Molecules of a substance attract each other with a force, which varies inversely with the distance between them. Temperature of a substance is directly proportional to the average kinetic energy of molecules. 4. The motion of molecules depends upon the state of matter and nature of molecules. For kinetic energy and temperature of molecules can be increased by compressing the matter. Brownian motion. The zigzag motion of tiny suspended particles in liquids and gases is known as Brownian motion. Explanation. According to kinetic theory, molecules of gases and liquids moves freely in random directions. Since molecules are very small, therefore their motion cannot be observed directly. Robert Brown in 1827 used tiny particles such as pollen grains to observe the motion of liquid molecules in gases. Smoke was used to observe molecular motion. In both the cases, suspended particles were found to move along zigzag paths. This type of motion of suspended particles is due to collision between the particles and the molecules of the liquid or the gas. It is known as Brownian motion. State of matter. There are 3 states of matter: 1 solid, 2 liquid, 3 gases, 1 solid. 1 solids has definite shape and definite volume. 2 in solids, intermolecular forces are strong because the molecules are very closely packed. 3 molecules vibrate about their mean position. 4 molecules cannot flow. 5 solids can be compressed negligibly by applying high pressure. 6 solids expand on heating. 2 liquids. 1 liquids have definite volume but no definite shape. 2 in liquids, the molecules are close but force of interaction in between them is not strong as in the case of solids. 3 molecules of liquids can freely move within the liquid. 4 molecules of a liquid can be compressed. 5 liquids expanded on heating and change into gas. 6 liquids contract on freezing and change into solids. 3 gases. 1 gases neither have definite shape nor definite volume. 2 gases molecules are far away from each other, because intermolecular forces are very weak. 3 molecules of gases moves freely and change their positions. 4 gases molecules exerts pressure on the wall of container. 5 gases molecules can be compressed easily. Elasticity. A phenomenon in which a material body comes back to its original shape after the removal of deforming force, is called elasticity. Elasticity body. Every solid possessing the property of elasticity is called elastic body. Elastic limit. The maximum resisting force of a matter is called elastic limit of the matter. If a greater force of elastic limit is applied to change the shape, then after removing the force, matter cannot regain its original shape. Stress. Deforming force per unit area is called stress, or the opposing force per unit area exerted by the body to resist a change in its or shape is called stress. Notation. It is denoted by the Greek letter sigma units. In SI, system unit of stress is nm squared. In GS, system unit of stress is dicm squared. In FPS, system unit of stress is IBS ft squared. Strain. Relative deformation caused by stress is called strain, or the change in length, volume, or shape produced by stress is called strain. Notation. It is denoted by the Greek letter epsilon. Longitude strain. The change in length per unit original length of the body is known as longitudinal strain. Or if relative deformation is in length, then it will be longitudinal strain. Formula: strain unit. Strain is a ratio of two similar quantities, so it has no unit. Hooke's law. Stress is directly proportional to the strain within the elastic limits. Mathematically, where K is constant of proportionality. Young's modulus. The ratio in between the stress and longitudinal strain is called Young's modulus. Notation. It is denoted by Y formula. According to Hooke's law unit, the unit of Young's modules in SI unit is Nm squared pressure. The perpendicular force exerted per unit area acting on a surface is called pressure. Formula: pressure equals force area P equals FA unit. The unit of pressure in SI unit is Nm squared. It can also be named as Pascal and it is denoted as Pa. 1 Pascal. If a force of an acts on an area of 1 meter squared, the pressure is 1 Pascal. Fluid. The substance which can flow in a pipe by virtue of pressure is called fluid. All the gases and liquid are known as fluids. Example: water, milk, honey, petroleum, oil, smoke, power, air and gas, etc. Pressure of liquids. Consider a container of area cross-section A having a liquid of density P into whose depth is h. Them. Area of cross-section equals A. Density of liquid tongue sticking out. Depth of liquid equals h. Volume of the liquid equals V equals I. We know P equals mVm equals PVm equals AHP. Weight of liquid W equals APG. As W equals mg. Same as the force acting over the bottom of the container, which is an area A. We know P equals FAP equals WAP equals APG. AP equals HPG. From above relation we concluded that 1. Pressure is directly proportional to depth. 2. Pressure is directly proportional to density. 3. It is directly proportional to the G. Pascal's law. If a pressure is exerted on a liquid, the liquid will transmit this pressure equally in all directions. Example: this law can be explained experimentally by taking a vessel which is connected with 4 similar pistons, fill it with water and note down the position of every piston. Apply some pressure in one of the piston. We will observe that all the piston will go out equally. This shows that water transmits the pressure equally in all direction. Hydraulic machine. Some hydraulic machine are 1. Hydraulic brake system, 2. Hydraulic lift, 3. Hydraulic press, 4. Hydraulic jack. Hydraulic brake. Hydraulic brake is based upon the principle of Pascal's law. It consists of a master cylinder joined by tubes to 4 smaller cylinders. These are called brake cylinders. All the cylinders are provided with oil-tight pistons. Working. A forward push on the brake pedal applies a force on the piston of master cylinder. This pressure is transmitted to every brake piston equally according to Pascal's law. This force increases considerably because area of the brake piston is greater. This greater force opens the brake shoes, and due to friction in between brake shoes and drum of wheel, the automobile stops. When the pressure on the brake is released, the spring which connects the brake shoes contracts and pulls them away from the rotor. The wheel is then free to rotate again. Uses: 1. It is used to stop the vehicles. 2. It is used to control the speed of the vehicles. Hydraulic lift. It consists of 2 cylinders. One is of smaller area and other of greater area. Both the cylinders are fitted with airtight piston and connected with each other with the help of tube filled with incomprehensible fluid. Working. A pressure is applied downward on a narrow piston which transmits the pressure equally according to Pascal's law on wider piston. Hence, to keep the pressure equal, force will increase and wider piston rises up along with the car resting on it. Uses: 1. It is used to lift heavy vehicles such as cars and buses for repairing purposes. 2. It is used to lift vehicles for services purposes. Hydraulic press. In hydraulic press, a narrow cylinder A is connected with a wide cylinder B and they are fitted with airtight pistons. It is filled with some incompressible fluid working. When pressure is applied on the cylinder A by moving the piston, the pressure so applied is transmitted equally according to Pascal's law to the piston of cylinder B. The piston B, which is used to lift the object, is provided with a rigid roof over it as shown in above diagram. When the piston of the cylinder B moves upward, it compresses the material between the rigid roof and this piston. The hydraulic press is used for compressing soft materials. Example: a hydraulic press compresses cotton into compact bale, powdered materials into compact solids. Atmospheric pressure. Pressure exerted by atmosphere is called atmospheric pressure at sea level. The value of atmospheric pressure is 1 atmosphere. Barometer. Barometer is a device which is used to measure atmospheric pressure. Mercury barometer. Mercury barometer consists of 1 meter long glass tube closed at one end and a mercury bath working. Fill the tube with the mercury. Cover the open end with thumb firmly and invert the tube in a vessel containing mercury. Remove the thumb. Some of the mercury will fall in the vessel. The length of the mercury column in the tube is referred to as the atmospheric pressure, which is 760 millimeters. Aneroid barometer. It consists of a partially evacuated corrugated steel box, which is attached with a strong spring and system of levers and a pointer working. When air pressure rises, the top of the box is pressed inwards, and when the pressure decreases, the top moves upward. Movement of the lever moves the pointer on the calibrated scale. Archimedes S Principle. When an object is immersed in any liquid, an upthrust acts upon it which is equal to the weight of the liquid displaced by the object. Upthrust equals weight of liquid displaced. Verification. To verify the above statement, we consider a uniform solid cylinder of cross-section A submerged in a liquid density P. Let its upper faces at a depth h and the lower one at h2. If Pa is the atmospheric pressure, then W is the weight of liquid displaced by the cylinder, which is equal to the net upthrust. Hence Archimedes' principle is verified. Apparent weight. Due to upthrust, an object immersed in a liquid has an apparent weight which is given by following formula. Apparent weight equals actual weight of the liquid displaced by the object. Law of floating. A floating body must displace liquid equal to its own. Explanation. According to law of floating, buoyancy equals weight of displaced liquid. Hence we can define the above law as follow. If buoyancy is equal to the weight of the body, then it will float. Submerged can float and can sink. This is because of the large hollow ballast tanks. Normally these tanks are empty and weight of submarine is less and it can displace liquid equal to its weight, hence it floats. When it wants to sink, then water is allowed to enter into tanks, which makes the submarine heavy. Volume remains the same, so it cannot displace liquid equal to its weight and sinks down. Condition for flotation. When a body is immersed in liquid, its weight is acting downward and the upthrust of the liquid acts upward. 1. If the weight of the body is more than the upthrust, it sinks. 2. If the upthrust is more than the weight of the body, it floats. Buoyancy or upthrust. When an object is immersed in a liquid, it displaces liquid equal to the volume of the object immersed in the liquid, and the object experiences a force upward equal to the weight of displaced liquid. This upward force is called upthrust or buoyancy.